Okay, in this section we will discuss about Lagrange's interpolation, and this Lagrange's interpolation can also be used to find the missing data or any y value corresponding to any x value which is not present in the given data set, that you can find out by using this technique. So here we have some x values which maybe it is equally spaced, but mostly we can also use this particular technique even if this x values in the set of in the data set given which is not equally spaced. Okay, in those cases also we can use this Lagrange's interpolation technique. Also, if you consider n plus 1 data points in this case, as we discussed earlier, if you are having n plus 1 data points, then we can have the highest degree of your polynomial should be n. Okay, so let us consider n plus 1 data points, which is like this: xi comma yi with I equal to 0, 1, 2, 3, etc. Okay, so up to n, we can run this I, so that we'll get n plus 1 data points. So all those xi's need not to be equally spaced. Okay, they may be equal spaced, but it is not necessary. So you can have something like x value 1, 2, 3, 4, 5, etc. So these are equal spaced, but if you're considering like 1, 2, then 6, then 8, something like this is also possible for x values. Okay, so the x values may not be or it need not to be equally spaced in this particular interpolation technique. So if you are having n plus 1 data points which are given, and then we can find out a polynomial of degree n. Okay, and say let us consider that polynomial as ln of x, Lagrange polynomial with degree n, in such a way that ln of xi should be equal to y of xi, which means this value Lagrangian polynomial, Lagrange's polynomial, okay, that will give you the corresponding y value. So ln of xi, this point for this x value, if you calculate what is ln of xi, then that will be equal to y of xi, which means that this will be equal to y value corresponding to that x value, okay, which is nothing but yi. So that is what we have to calculate by using this interpolation technique. So if you don't know what is the y value corresponding to that xi value, ith x value, then you can use this Lagrange's interpolation, find out what is ln of xi, and you will be getting corresponding y value for the unknown x value. So let us consider this first case, case 1. We are provided with 2 points here. One is x0, y0, and the second one is x1, y1. So this is the simplest case that we can consider. We are having 2 points, 2 data points which are given, and what will be the Lagrange's polynomial interpolation or the polynomial equation. So this is we are having only 2 points, so which means that it can be only a straight line. As you can see from here, we are having 2 points. So the simplest polynomial that we have 2 points means 2 points implies the degree of polynomial that should be equal to 2 minus 1. If you are having n plus 1 data points, then n will be the degree of polynomial, highest degree of polynomial. So this is 1. This is the highest degree of polynomial, which means that this is like mx plus c or something. This kind of polynomial you can have. But this is nothing but straight line. If you're having mx, that is straight line. So here the polynomial degree is 1. So that is varying with respect to x, x raised to 1. So with 2 points, you can have a straight line like this. Okay. And if you connect those points, I have plotted here. These are the 2 points. Let us consider A and B are the 2 points which is uh, available to us. So this x0, y0 is corresponding to this point A, and x1, y1 is corresponding to point B. And these 2 points, with these 2 points, we can make a straight line. Okay, so from figure, this is corresponding to y1, this is y0. So y0 in this y-axis, we have this y0, and correspondingly, we have the x value, which is x0. And for x1, we are having y1 value corresponding to x1. We are having y1. That is 2 point that we have. So let us consider like let's say 1 and 2, which are given for x, and 2, 4 are for y. So this is corresponding to those points with x-axis x0 as 1 and y0 as 2. And then here we are having x1, which is equal to 2, and y1, which is equal to 4, something like that. So from figure, we can consider this straight line, and the slope of AE, this slope of AE should be equal to slope of AB. So if you consider this line here, this line, the slope of this line should be equal to slope of this line because it is the same straight line. Okay. So in that condition, what is slope of AC? Slope of AC will be equal to delta y. I will just use another color here. So let us consider this AC, straight line segment AC, this part. So in that part, what is delta y? Change in y is nothing but this Lx, L of x, that is the y value or Lagrangian point corresponding to this x value. Y value corresponding to this x value, that is L of x. So, okay, this is L1 of x, not L of x. So this, I'm just taking it as L1 of x because we are considering order degree, highest degree, which is equal to 1. The degree I am representing by using L1 here, okay? Because we are considering Lagrange's polynomial as Ln with degree n, okay? So here we are having only the highest degree, that is 1. So L1 of x is the y value which is corresponding to this x value in this case. And in this case, delta y or dy will be equal to this L1 of x minus this y0. That is the difference in y-axis for this straight line up to E, from A to E. So for AE straight line, we are having change in y as L1 of x minus y, sorry, y0. Okay. And change in x is nothing but this is x and this is x0. So the change in x will be x minus x0. So that what we have written here. Slope of AE is nothing but L1 of x minus y0 divided by x minus x0. That is change in y divided by change in x for that particular straight line AE. Similarly for AB, if you consider, that is for all this straight line from A to B, if you consider, what will be the slope? Slope will be y1 minus y0, that is here, y1 minus y0, you can see here. You can directly take it or you can split it, no problem. So anyway, in the denominator, you are having this x1 minus x0. Okay, so you can take y1 minus y0 by x1 minus x0. So if I consider it like this point as my y, y1 for this b, and y0 is for this a. So I can split it like this: y1 minus y0 divided by x1 minus x0. I can write it as y1 by x1 minus x0 minus y0 by x1 minus x0. Now you just take this x minus x0 into the other side, then you can write it as x minus x0 divided by x1 minus x0 into y1 minus x minus x0 by x1 minus x0 into y0. Now take this minus y0 to other side, then it will become plus y0. So I have written that term here. Then I am considering this term first, okay, with minus. So y0 minus x0 by x1 minus x0 into y0 plus, then I am considering this term x minus x0 by x1 minus x0 into y. This, it is just for the order. We are having y0 here, y0 here, then y1, then y2. In that order we have to go. Okay. So now if you rearrange this particular equation, which means after cross multiplication of this x1 minus x0 with this y0 and subtract that from x minus x0 into y0 from here and divided by x1 minus x0. If you do that, then you will get the equation like x minus x1 divided by x0 minus x1 into y0. So actually you have to do this like, I hope you understood that, that what you have to do, y0 minus, sorry, x minus x0 divided by x1 minus x0 into y0. So this x1 minus x0 you have to cross multiply with this y0. So that will come y0 into x1 minus x0 minus y0 into x minus x0, right? Divided by x1 minus x0. So now if you multiply y0 into x1, y0 into x0, so this term will become minus y0 minus, so that is minus y0 x0 will come one term. That minus y0 x0 here, and we are having minus y0 into minus x0 here. So those terms will get cancelled each other. And then we have y0 x1 here, then minus y0 x. Okay. So in that sense, so if you rearrange these terms, then we can write the equation as x minus x1 by x0 minus x1 into y0 plus x minus x0. That term remains as such. Only the first term is going to change because we are cross multiplying that with y0. Okay, so we'll get this equation. This term remains as such. Okay, this term you have to cross multiply and subtract the terms, and then you'll get this kind of expression. And this term x minus x1 divided by x0 minus x1, I am calling it as L0. And this term x minus x0 by x1 minus x0, that I am calling it as L1. Okay, so L0, L1. And in that case, I can write L1 of x will be equal to L0 into y0 plus L1 into y. So where L0 will be x minus x1 divided by x0 minus x1, and L1 is x minus x0 by x1 minus x0. Now, from that, we can have some condition here. If you consider L0 of x0, what will be that? L0 of x0? L0 of x0 will be, if you substitute x0 for x in this equation, so what will, so that will come x0 minus x1 divided by x0 minus x1, this term, when you substitute x0 for x in this particular equation for L0. So this will be x0 minus x1 by x0 minus x1. That is nothing but 1. But in both the denominator and numerator, we are having same term. So this will become 1. And that is also equal to L1 of x1. What is L1? L1 is this term. You consider L1 of x1, which means that you have to replace this x with x1. So that will become x1 minus x0 by x1 minus x0. That is also 1. So L0 of x0 will be equal to L1 of x1 equal to 1. Similarly, if you consider L0 of x1, which means that in this L0 we are substituting x1 for x. So this numerator will become 0. So L0 will become 0. Similarly, if you substitute for here if you substitute x0 for x, then this term also will become 0. So L0 of x1 will be equal to 0. Similarly, L1 of x0 also will be equal to 0. These are the two conditions. So in general, we can write Li of xj, Li of xj, this term, that will become 1 when I equal to j. And that will become 0 when I not equal to j. That is the condition. Now we can also write these equations as a matrix form. You can see from here. So this is the equation a0 plus a1x equal to L1 of x, and then we can write a0 plus x0 a1. So this is general equation for x. Okay, but we do not know what is this x, that we have to provide. We don't have that value. We have only x0 and x1, two x values, and we are also having y0 and y1, two y values correspond to these x values. So a0 plus x0 a1 will be equal to y0. That is the second equation. So in general, we can write it like this. The first equation a0 plus any x value, x into a1, that will be equal to L1 of x. And in the second equation, we can clearly say a0 plus x0 a1 equal to y0, a0 plus x1 a1, that is equal to y1. This is simply the straight line equation. Okay, so we are having a constant a0 plus some x value into a1, and that will be equal to some y value. That is nothing but L1 of x for this case, because we are considering order of polynomial as 1. So this is L1 of x. So if you consider the other 2 points, then we can write a0 plus, that is first point is x0 times a1 should be equal to y0, and a0 plus x1, that is the second point, second value of x, that is in x1 into, if you consider again a1, then this will be equal to y. So these two are representing the straight line, as you can see from this point. Okay, so this is your point x0, y0, that is given for you in the data set, and this b will be x1, y1. So with those 2 points, we can construct straight line like this. Okay, so now you consider those metrics, and from this simultaneous equation, we can say for simultaneous equation, the coefficient matrix determinant must be equal to 0. Coefficient matrix, it has to be determinant. To take the determinant of the coefficient matrix, then that will be equal to 0. Then we can write it as determinant of L1 of x, 1 x, y0 1 x0, y1 1 x1, that will be equal to 0. Determinant of the coefficient matrix will be equal to 0. So then we can write it, if you solve this particular equation, this particular matrix, which is equal to 0, why it is equal to 0? Because we are considering those simultaneous equation, and for simultaneous equation, the coefficient matrix determinant must be equal to 0. That is condition. So this will be equal to 0. This is another way of representing the same equation by using matrix method. Okay, we are having those that equation here. You can see that L1 of x is nothing but this equation. L1 of x is nothing but this. L0 times y0 plus L1 times y1. We are looking the same with this matrix method, and we are considering the coefficient matrix as this, and its determinant should be equal to 0 because we are considering simultaneous equation here. And if you solve this determinant, this equation, then we can construct L1 of x will be equal to x minus x1 by x0 minus x1 into y0 plus x minus x0 by x1 minus x0 into y. This is same, equation is same. This is nothing but your L0. So this is L0 times y0 plus L1 times y1. This is same. Equation is same. Just we are representing it is in matrix form, in determinant. So if you are having 2 points, you can have this kind of straight line. This equation L1 of x, that is for the Lagrange's polynomial equation corresponding to any polynomial of degree 1. But when you consider 3 points, you can have polynomial of degree, maximum degree that you can have, that is 2. Okay. So now we are calculating what will be the equation for the Lagrange's polynomial when the degree is 2. So in that case, we'll get L2 of x. Okay, so this is the general equation for that particular polynomial. L2 of x will be equal to a0 plus xa1 plus x square a2. So whatever x you are substituting here, that corresponding y value will get for with this Lagrange's interpolation, Lagrange's polynomial equation. So this is nothing but your y of x for this x value, that is unknown. Okay, but we know 3 equations. 3 points we know. Correspondingly, we have 3 equations. That is nothing but y0 will be equal to this quadratic equation, as you can see from here. So here we are having quadratic equation because we are having 3 points. So we will be having polynomial of degree 2. Okay. So degree 2 will be corresponding to quadratic equation. It is not a straight line. Okay. So we are having 3 points. So for all those 3 points, we can have these kind of equations for y0, y1, y2, corresponding to x0, x1, and x2. We are having 3 equations. And in general, we have this equation for if you are having 3 points, then you can have a Lagrange's polynomial of order 2, and the equation will be like this. And from that, you can also reduce these equations into this matrix form L1 of x, y0, y1, y2. And then we are having this 1, and then x0, x1, x2, x square, x0 square, y x1 square, y x2 square. This is same. Just we are constructing that coefficient matrix. So here we are having a0, that is 1, 1, 1, 1, 4, 1, 1, 1, 1. And then we are having this a1 here. So this has to be multiplied with x, x0, x1, and x2. So that is this column. Okay, then we are having the square term. Okay, so considering those coefficient matrix, this has to be equal to 0. And you will get the L2 of x. If you solve that matrix, this determinant, then you will get x minus x1 into x minus x2 divided by x0 minus x1 into x0 minus x2 into y0 plus x minus x0 into x minus x2 divided by x1 minus x0 into x1 minus x2 into y1. Similarly, x minus x0 into x minus x1 divided by x2 minus x0 into x2 minus x1 into y2. So this is the expression for L2 of x. Okay. So this is x. That x value we have to put in this equation because we don't know what y value you need to find out from this corresponding to which x value. Which x value, which y value you need corresponding to which x value. That x value you have to substitute here, then you can get corresponding y value after solving this. This is nothing but y of x. So in this case, we are having L0, Y0, L1, Y1, and L2, Y2 also. So we are having 3 terms here. And this L0 is this one, and this L1 is this one, and this L2 is this one. And remember that when you are calculating for Y0, the coefficients you can see from here. For with this Y0, we can see we are not having any X0 terms in the numerator. We are having only the other terms, x minus x1 and x minus x2. X0 will not be present in numerator. This is how you can remember this equation. So if you are multiplying with y0, you will not be having any x0 in the numerator, but in denominator you will be having x0 minus x1 and x0 minus x2 because you are calculating for y0. So you have to subtract the other 2 points from x0 in denominator. Similarly, you can see here you are calculating for y1. So y1 terms, x1 term will not be present in the numerator. So you have to subtract x from x0. So you have to subtract x0 from x, and x2 from x1 is absent because you are calculating for y1. Similarly, in the denominator, we are subtracting x0 from x1, x2 from also from x1. Here we are subtracting x1 from x0, x2 from x0, but here we are subtracting x0 from x1, x2 from x1. So here we are calculating y1, so we have to subtract the other 2 points from x1 in denominator. And in numerator, we have to subtract x0 and x2, other 2 points from x. This is how, then you have to multiply those terms, and this is how we can remember this equation. Okay, now we will go to the generalized equation. In general, we can write the determinant like this for n data points. You can consider. So for this is n plus 1 data point. Okay, n plus 1 data point and nth degree polynomial. So L1 of x is here. I think you can write it as Ln of x. So that will be equal to L1 of x, 1 x, x square, x cube, x raised to 4, like that it will go, and up to xn. It is just a generalization. Here you can see in the last case we have taken matrix L1 of x into 1 x, x square, like that. And this is also, I think, should be L2, right? Should be L2 of x, then only 2. And so on. So we can write this as ln of x is equal to, sorry, ln of x, then we have y0, y1, y2 up to yn. Okay, so considering n number of n plus 1 data points, so we are having n such kind of equations you can see from y0 to yn. Okay, so in total we have n plus 1 equations, including this general equation ln of x. So that will be giving you this determinant equal to 0 because we are having simultaneous equations in this case also. And if you solve this particular equation, then we can have this kind of expression. And we have ln of x, which will be equal to summation of this I equal to 0 to n li by I. So this is nothing but like L0 y0 plus L1 y1 plus L2 y2 plus and so on plus ln yn. This is the general equation. And from that, li of x, what is li of x here? Li of x will be whatever it is, L0, L1, L2, whatever it is. So li of x, this term will be equal to x minus x0 into x minus x1 into etc. X minus xi minus 1, x minus xi plus 1. Remember that x minus xi is not there. It will not be present in numerator. Xi term will not be present because we are calculating for li, which means if you are calculating for L0, x0 will not be in the numerator. If you are calculating for L1, then x1 will not be in the numerator. X1 term, that is x minus x1, will not be there. And so on. Okay, so for Li, if you are calculating, then xi, x minus xi term will not be there in numerator. All other terms we have to subtract, all other points we have to subtract from x, x0, x1, x2, all those points we have to subtract from x. And that has to be multiplied in numerator. And in the numerator, it is like that. In denominator, we will be having the corresponding point, that is xi. This is xi minus x0, xi minus x1, xi minus xi minus 1. So all those other points which has to be subtracted from xi in denominator if you are calculating for li, which means if you are calculating for L0, this will be x0. So in that case, you don't have to subtract x0 minus x0, because in that case, in denominator, we have to subtract all the other values from the value that you wish to calculate. Okay, in that case, For example, if you are having L0, then in denominator, if you are calculating L0, L0 means corresponding to X0, right? So L0 means the L0, if you are calculating, then X0 terms. Then you have to substitute all other values from X0. So X0 minus X1, X0 minus X2, like that it will go. X0 minus X0 is not possible in that case. That is what we have written the condition first. Okay. So in that case, we have to subtract like this: X0 minus X1, X0 minus X2, X0 minus X3, up to X0 minus Xn in denominator. Similarly, if you are calculating for X1, then we will be having X1 minus X0 into X1 minus X2. X1 minus X1 will not be there. X1 minus X2, X1 minus X3, and so on up to X1 minus Xn. So that is the terms that you can have in the denominator. Then those terms will be multiplied. Okay, so this is the general form for the Lagrange's equation, Lagrange's polynomial equation. This one, okay, is generalized equation. And for here, Li is defined like this. Li of x will be like this. So that is the general Lagrange's polynomial equation. Now let us consider an example. You have this set of data. So here we have how many points? 4 data points are there. 4 data points, which means that we can have the highest degree of your polynomial, which is equal to 3. So this is the highest degree of polynomial that you can have with this 4 given data points. So those are 1, 4, 5, 7. So the data points are 1, 2, then 4, 6, and then 5. Oh, 5 is not given, right? 5 is not given. So let us consider. So this we have to find out. So only 3 points are given. 3 data points are given, and the highest degree that we can have is 2. Okay, so 5 is not given, so 5 we have to find out. So then we have 7, 18. This is the data. Now, what will be the value of y corresponding to the x when x is equal to 5? That is what we have to find out. What is the value of y? Okay, so in that case, y will be equal to L2 of x. Why it is L2 of x? Because highest degree is 2 now. That is the possible highest degree possible with 3 points. So L2 of x will be equal to x minus x1, x minus x2 divided by x0 minus x1, x0 minus x2. And this is corresponding to y0 equation. So this is L0 for that case. And for L1, we are having this equation, that is x minus x0, x minus x2. In numerator, we do not have x minus x1 because we are calculating for y1. And in denominator, we will not be having the x1 minus x1 term, but other terms we have to consider x1 minus x0, x1 minus x2. And similarly for third term also. So we will get L0 times y0, L1 times y1, L2 times y2. And if you add all those terms, then you will get what is the corresponding value for this L2 of x. In this case, L2 of y, if you want to find out. Then you have to subtract this, you just substitute x equal to 5 in all these points, in these positions. Here also 5, here also 5. Then put what is x1, x2, x2, x0, all those values. And those values are given here. This is your x0, this is your x1, this is your x2. This is the x where you have to find out the y value corresponding. Okay. That you have to substitute and find out what is this L2 of 5. That will be equal to your y of 5. This is how the Lagrange's polynomial works. Now let us consider the algorithm for this particular program for this Lagrange's interpolation. And the algorithm will be like this. First, you have to store all the data points that is given, that is in X and Y. So all the X values we have to store as a list, and we call that as list as capital X. And then we have all the Y values, which we have to store as another list with a name, which is Y. Okay, so these two are representing the given data points, which is stored as list. Okay, and then we have to store the X value. This is not a list, but this X value is corresponding to the Y value that we have to determine. So this X value we have to provide at what X value you need to find out the Y value. So this is X where Y has to be evaluated, and that has to be stored as X, variable X. And then we have to find the number of X values that is given, that is the total number of data points, or you can consider this as number of Y values also that is given. Okay, or the number of data points you can consider. You can write this as number of data points. Find number of data points, and that has to be stored as n or small n or capital N, whatever it is. Okay, that you have to store. Okay, that is total number of data points. We need that number of data points because we have to find out which degree of polynomial we have to consider. So it is possible only if you are having this data point, and we have to consider uh, n plus. If you are having n data points, then your degree of polynomial must be equal to n minus 1, right? Maximum degree that is possible. Then we have to initialize y as 0 because we do not have any y value now. This y is not this list. This is capital Y. This is capital Y. This one is small y. And this y is the value of y corresponding to this x value. And that let us consider initialize that as a 0. Then execute a loop. Then execute a loop to calculate the ith term liyi and add that term into y. Okay, so in each time, for example, if you want to find in this equation that you are having, if you have provided three data points in here in this equation, in this example I am saying, you are provided three data points, which means that your highest degree possible is 2. Okay, so your y, you have to find out y which is equal to L2 of x will be like this, which is nothing but L0 of y0 plus L1 y1 plus L2 y2. This is what you had to find out for L2 of 5 if you're calculating y value for 5. Okay, so that is, in order to calculate this, you have to consider a loop, and first you have to calculate what is L0, and you have to multiply that with y0, and you have to add that with y. What is y value now? Y equal to 0 in this case. Initialize y equal to 0. You can see from this step. Initialize y equal to 0. So with this y value, we have to add L0 y0. And then you have to calculate what is L1 y1. So for that, first we have to calculate what is L1. Then multiply that with y1 that is given. And those values you have to add with this y again. Again, you have to find out what is L2. Then you have to multiply that with y2 and add this product with this y again. Okay, so then we will get the total y value corresponding to x equal to 5. So that is how the loop will work. So that is this last step that you can see from here. This one, yes. This one. Each li yi you have to calculate, okay, and add those values into y, and you will get finally the value of y. So that is the algorithm, and this is the program. Okay, list eval input x points separated by comma. Okay, And then we have the y value that you have to give as an input, and that has to be separated by comma. So this will be stored as a list. For that, we have given this list option here. You can see my pointer is list. So this x and y values, which are capital X and capital Y, which are considered as a list of values. Then we have this eval. This eval function will give you the exact type of the data that we have used in this particular list. For example, if you have used integer type data in that list, then it will directly give you integer. If you are using float, then it will directly give you float values. So you don't have to specifically say this is int of input like that, or float of input like that, or a string of input like that. So just you have to use this eval function, then it will automatically give you whatever you have given in this x points separated by comma. So if it is integer, it will directly give as integer for this x list. Similarly, for the y list also, it will give the same integer or float whatever we have given. So that for that we are using this eval function. So you don't have to specifically say this is integer or float like that. You can use eval, then that will directly give the list of values as integer or float. Similarly, here also in this x value we have used this eval, then whatever we have given is for this x value as integer or float, that x value also will be considered as that same data type. So whatever we have given as input, that will be considered as the data type in the case of x value also. So this x value that we have, that is the y value, that is we have to find out for corresponding to this x value, and that we have to provide as an input into this program, and the corresponding y value that we had to find out by using Lagrange's interpolation. And then we have this n, which is the length of x. We can consider it as small n. I have written it as small n. So n will be equal to ln of x, length of x, which means that length of, this should be capital X, that is the length of the list, capital X, that you have to consider here. This list, which means that the number of data points that is given, that we have to get. So n is length of list, this list. Why we have to consider length of list? If you are having, let's say, some 3 points, then 2, 3 in x, and correspondingly we have some values in y also. So if you are having this kind of data set, then we are having 3 points, which means that you should have a degree of 2, maximum degree of polynomial should be equal to 2. And if you consider the length of this list, then what will be the length of this list? It will be 0, 1, 2 is the index that you have. So 2 is the index value corresponding to this term 3, this point 3. So this is the length. So this will be also equivalent to your degree. 3 points, 2 degree. Degree of polynomial should be equal to 2. So the length of this data points that is given, the list that is given, the length of this list will be equal to the value of n, that is the degree of your polynomial. And then you initialize y equal to 0 here, y equal to 0, that is initialization. And for I in range, these two for loops are for calculating L0, so that is Li terms. So first I will consider, so up to this is okay, y equal to 0 is the initialization for y. Then let us consider this one. Okay, let us consider Li equal to 1. Li equal to 1. And in that case, oh, this is already there, so we don't have to consider here. This is already I have written here. So this Li is initialized here anyway. So that is, let us consider first this loop, that is the inner loop. So for I, for j in range of n, let us consider this as small n. So for j values in range n is length of that list. So let us consider this n as, for example, in this case, let's consider 2. 3 points are given. So j is starting from 0 and it is up to 2. For j in range 2, so for range n up to this, if I is equivalent to j, continue. Which means that if I is equivalent to j, then we have to just skip this particular step. Okay. What is this step? This is the calculation for Li. Li will be equal to Li star, Li star, Li multiplied with x minus xj by xi minus xj. This is general expression. Okay. So in all those j values, we have to calculate these terms. That is the loop that we have to consider. And this first will come from this for loop. So for loop, we are having I in range n. So where n is equal to 2. So I start from 0 to 2. Okay, first it is 0. Then Li equal to 1. I initialized Li equal to 1, which means that L0 is equal to 1 now, because my I is equal to 0 now. Then I will go to this loop, for loop. Then for j in range n, which means that j is also varying from 0 to 2. So j I am considering 0 here. And in that case, I am just checking this condition, if I equivalent to j. In that case, I know this is 0, this is 0. So I just go to, if this condition is satisfied, then I will go to this step, then continue. Continue means we do not have to run the remaining steps in this loop. Then I will just go to the for loop again. Then this for loop I will go, and then I will sorry, this for loop inside, because we are continuing from here. So it will go to, again, this for loop, and j will be incremented in this case. So j will become 1, and in 1 in, so 1 in that case I is still 0. This will become 1. J is equal to 1. So it will go to, it will not go to this step now, because I is not equivalent to j. So it will directly go to this step, and Li is now L0. L0 will be equal to Li star, which means L0 star into, so this will be x minus xj. X I have given. Okay, so x is given, for example, in this case, anyway, I will put it as x itself. X minus x of j. X of j means x of j is now 1, x1. Okay, divided by, what is this one? X of I. X of I is x0. I is 0. X0 minus x of j. X of j is x1. So this is the first term. L0 into this term. Right? And this is not whole. This is not all. In the next case, what will be the, it will go to the, again, this for loop. J will be incremented by 1, and it will become 2, as you know, 0 1 2, and this loop continues. Okay, so it depends on how, what is the, I'm just giving this number as 2 when we are considering 3 data points. So it depends on the value of which, how many number of data points you are having, length of this list that you have defined. So depending on that, this terms will be increased. So in the next one will be x minus x2 divided by x0 minus x2. So this has to be multiplied. So that is how it will work. This program will run, and next time it will not go, it will not run, so that we will not be having, because next time it will go beyond that range. Okay, beyond range of that n, which means n is nothing but length of that list. So if you go beyond that, then it will exit. Then it will go to the for loop, first for loop. Okay, so in that case, we had to consider the first for loop. After executing this term up to this term, what will happen? to this term. Another up to this term it will go. Now we are j equal to 2. Again it will go to this for loop. Now j is 2, so that is more than this range. Range of n is 2. So then it will exit this for loop. Okay, so that will go then into this step. Then your y will become y plus. What is y value? Y value is 0 now. We are initialized to y value equal to 0. 0 plus li. Li is nothing but L0. Okay, that we have calculated here. L0 will be equal to all these terms. Okay, that is calculated. And L0 into y of I. Y of A is y0. Okay, so L0, y0 we are added with this y. And so which means that this is equal to 0. Okay, so this will give you y equal to L0, y0. Now again it will go to the for loop. Once this step is over, then it will increment this I. I will be increased to 1, from 0 to 1. Then again this will repeat. Li will be initialized as 1. Okay, and I is 1, j is 0 now because we are starting from 0 in this loop. J is 0. Then you will be getting L1 because I is 1. Li will be L1. L1 will be equal to L1 times. So here we will be having L1 equal to 1 because now your I is equal to 1. So L1 times you'll be having those terms. Now your x is there, x minus x of j is x0 divided by, then you are having next term, that is x of I. X of I is x1 minus x of j is x0. Similarly, we will be having second term also multiplied with this x minus x1 divided by x1 minus x2. So L1, you got L1, then you will be going to the next step here, and then we'll be getting added up with this L0, Y0, because now your y is L0, Y0. So L0, Y0 plus this term, which means that L1, Y1. Now your I is 1. So it will become L1, Y. And next time also will come L2, Y2. So once this is reached, then your 2 ranges 2 up to 2 is over. Then it will exit this for loop. It will directly go to this print statement. Okay, and then that y value will be printed. This y value will be printed. So this y is nothing but your L2 of x. This is equal to y of x that you have to find out. So let us consider the program now. We'll run that. I will just change this tab, this window. I will share the next another window here. I will just share this tab, this Stringer tab, where you are having that program. Okay. So I hope you can see this window. You can see the program here. Okay. So in this program, you can see first one I have imported numpy as npy, and the all other instructions we have already discussed. We have defined this list of x value as capital X, list of y value which is given, that is as capital Y. Then small x, that is the x that we had to find out. Then the n value, which is given as ln of x, and y is equal to 0, that is the initialization for y. You can see from here. I hope you can see that. And then we have given LA equal to 1 for a j in range n. So all these things we have already explained. Now I will just run that. This I have already. So okay. So this is the first. This line is representing import as numpy, import numpy as np. Then we are calculating all these steps. I think that is also not necessary. Okay, that is necessary because we are considering lists here. So if you want list, then we need this numpy. So then we are initializing this list x, y, that is nothing but the data points given. And this x is corresponding to the x that corresponding to that x value, we had to find out the y value. And then this n is corresponding to length of capital X, that is the length of that list, which is number of data points minus 1. And then we are having this y equal to 0, that is initialization for y. Then we are having to this for loops to calculate that L0 values, and that has to be multiplied with y0, y1, y2, like that. And we had to find out what is the total y. Okay, and print that y, that will be your answer. Okay, so let us run this. You can see this window also. Now first I have to put the x points. Let us consider 1, 2, 3, 4. Or I can give some non-cube spaced values. Let's consider some 5, then 10. And then we have y values which are, let's consider 0, 2, 3, some 4, some 8. I'm just giving some values. Okay, these are not the actual values. You can use any data set which is available. Now I have to find out what is the value corresponding to this particular x that I am giving. So if I put any value in this list x and y, it will give automatically the corresponding y value. If I put any other values, let's say 3 is not there in the list in x value. So I will calculate what is the y value corresponding to this 3 by using Lagrange's interpolation. Okay, but it is not working. Maybe I have some network problem. This is not connecting. Let me see it again. Let me check it again. Okay, exponents 1, 2, 3, okay, 5, 10. Anyway, points 1, 2, 5, 10 or something. Next value I will put 3. Okay. Now you can see 3.011 is the corresponding value for y when I put x equal to 3. This is how it will work. So this is the y value corresponding to the x value, which is. Now if I run it, let us consider the case when I am putting same value which is already there in this list. 8, okay, y value put 1, 2, or I can put something else. 10, 20, 80, 26. And if I put x equal to 3, then I will get the value corresponding to 3 in this list of values, or that data points that is given. Okay, so you can find out any unknown values if you put any x points, x values, which is already there in the list, then the corresponding y value also will be given. That is obvious, right? But you can find any intermediate values for this case. Okay, so that's how this Lagrange's interpolation will work. And let me see whether this. I will put one more. 2, some 4, 8, 10, 20, 40, 80. Let's consider some 2.5. So for any values, you can get the value corresponding to this x value that you have given. So this is with the Lagrange's interpolation. So basically, we are connecting those points with the polynomial of different order That polynomial is nothing but Lagrangian polynomial, and that will be having different orders according to the number of data points that we are having. So we are considering maximum ordered polynomial. So if you are having a different number of points when we are considering Lagrangian uh, interpolation, when you consider that, we are considering Lagrange's polynomial of order which is less than uh, less by one, okay, of the maximum number of data points available. Okay, in that way, if you calculate what is the y value corresponding to any x value, then you will get it like this. So that's all about the Lagrange's interpolation or Lagrange's polynomial technique.